This is part B of computing with scientific notation. It's adding and subtracting scientific notation. You can start a new page in your notebook, or if you want to keep going, you can do whatever you need to do. But this is part B of 4-5, computing with scientific notation. We're adding and subtracting today. Okay, so if you remember from the other day, we dealt a lot with the powers of 10 first, and then we took care of the first part of the scientific notation. Now, adding and subtracting are a little different. That's why I split this into two. When you add and subtract, you have to have the same exponent to add and subtract. It's kind of like when you add and subtract fractions, you have to have the same denominator. So when you add and subtract exponent, or when you add and subtract scientific notation, the exponents have to be the same. So that's going to be the trickiest part of today, but I think you'll be fine. So this is an example of when you have the same exponent. Okay? So this is an example of having the same exponent. So if you have the same exponent, it's just going to be 10 to the 5th. There's no adding them, there's no subtracting them. It's kind of like when you add denominators, when you add fractions, you don't add the denominators. The same thing is happening here. You're not adding the 10 and the exponents, okay? Then, the same thing from the other day, we're going to take these two things and we're going to add them together. Again, you can use your calculator. That's fine if we make this process go a little faster. 4.56 plus 2.31. And I get 6.87. And notice it's in correct scientific notation, so that's all I have to do. There you go. Now this is only an example of having the same exponent. My guess is you aren't going to get that lucky all the time and have the same exponent. So we're going to kind of focus on not having the same exponent so we can have some good examples about how to do that. All right, so here's an example of that. I have 5.97 times 10 to the 6th. And I have 7.35 times 10 to the 5th, and I'm going to add them together. So with that being said, I need to have the same exponent. I either need to make this a 5, or I either need to make this a 6. Now, to be honest, it's easier to take the higher exponent to the lower exponent, because most likely in the end, you won't have to rechange your answer. Your answer will most likely be already in the same exponent. Not all the time, but you have a better chance of having them be in the same exponent if you change them to the lower one to start with. So remember the other day when I said if you move the decimal to the left, your exponent, you will add 1, and if you move it to the right, it'll subtract 1. So I'm going to change this one right here to be a 5. So if I want to change 10 to the 6 to be a 5, which way do I have to move my decimal? Well, I want the 6 to be a 5, so I'm going to move it right because I want that 6 to become a 5. So if I move it 1 to the right, this is what it will look like. No, to the right. What am I doing? That's to the left. Okay. I moved it 1 to the right. Now I don't have to do anything with this one. This can stay the same. Okay. Now when I do this, my exponent stays the same. This I'm going to do, and I'm going to add them together this time. So I have 59.7 plus 7.35, and I get 67.05 times 10. All right, so in this case, I still have to rewrite it. So it probably will be it'll be to the 6th yet. So I have to actually move it over. Now, if I moved it over once to the left, I'm going to make it bigger one. So it's going to be 10 to the 6th. Okay, so like I said, the hardest part is going to be rewriting your scientific notation to get it to the proper format. So let's try this one over here. I have 1.02 times 10 to the 26th minusing 4.87 times 10 to the 24th. So I'm going to take, let's see, I guess it honestly doesn't matter to me. Let's change 26 to 24. So I'm going to change this to 24. Now to do that, let's go back. If I want to make it smaller, I have to move it to the right. And I want to make it 2 smaller, so I have to move it 2 to the right. So it would be 102 times 10 to the 24th. Okay, because I had to move it 2 to make it to the 24th. Now, I'm going to keep this the same. Okay. So, oops. Let's see, this is going to be to the 24th. I'm sorry, 10 to the 24th. Minus 4.87. So it's going to be 97.31. Okay, so I have to go like this. Times 10. I moved it once this way. It's going to be the 25. Maybe I said that wrong. Maybe you have to make your little one to the big one. I can't remember now. So you don't have to change it. There's one way that you can change them. You either make the bigger one smaller or the smaller one bigger, so you don't have to do much changing in your answer. So that's your answer for this one. All right, let's try another. So I have 5.45 times 10 to the third plus 3.12 times 10 to the fourth. Let's try to change the 3 to the 4 this time instead of trying to change it to the 4 to a 3. So I'm going to change this to a 4. And to do that, I have to move to the left once. Okay. And then this will stay the same. So this will stay the same. There we go. I'm not going to have to change this one. So it will be 5.545 plus 3.12. It'll be 3.665. There we go. So if you change the little one to the bigger one, most of the time you won't have to make much of a change in your answer. There we go. So like I said, the hardest thing is going to be changing those things and make sure you know which way it goes. Another thing you might have to do is you actually might have to write in scientific notation before you do anything. So if you remember right, let's write this guy in scientific notation. Be 4.65 times 10. Well, if I put it here, it's going to be 1, 2, 3, 4. Okay. And I'm minusing this time. So 2.78 times 10 to the 5th. I'm going to make the 4 a 5 this time. You could make the 5 a 4. Honestly, either way, you're going to come out with the same answer. So just because I do one way doesn't mean you have to do it that way. So I'm going to make this a 5. So to do that, I have to move 1 to the left. Minus. Okay, so that's going to be 10 to the 5th. Times. And then 2.78 minus 0.465. And I get 2.15. Awesome. Not much changing there because it's already in the same format. So yeah, I guess if you make the smaller one bigger, much of the time you will not have to change the answer. So it's kind of nice. Why don't you try one yourself? I'll give you one more. Okay. Let's change that 3 to a 4 this time. Okay, so I'm going to change this to a 4. I'm going to move it over 1 to the left. Okay. Okay, and sometimes I put parentheses around them to keep it together. This would be 10 to the 4th times whatever those. So this would be 7.449, and that would be your answer. Woo! There you go. You just did it. You computed with scientific notation. So taking some really, really big numbers and adding them in the scientific notation format so you didn't have to work with huge stuff on your paper. Let me know if you have any questions. I'll see you in class, and thanks for watching.